Good evening and welcome to Tinkering with Edkelar. Somehow I managed to receive, restore and make a video about this little device here, all within my 2-week cadence. Woohoo! So, fresh from the workbench, what is it? It is a Heathkit model number IM-1202 digital multimeter. I stumbled across it randomly when searching for Nixie tubes for my Residue calculator. So yes, this is a Nixie tube meter. But since it's a build-your-own kit, we cannot expect too much, can we? It features what we would call 200 counts today. Yes, 200. That means that 199 is the largest number it can show. There are 2 Nixies and 1 bar indicator neon for the leading one in it. Still, I think it is a neat device, and saving a Nixie tube based anything is always a joy. So, let's dig in! The power cord had the ground prong deleted. Well, I'll swap it over for a 240 volt one anyhow. My unit here was sold as suspected working, but with unknown state regarding the accuracy. Well, not that I'd expect too much in that field anyway. The inside looked rather cramped. The construction features a main PCB and a combined digital and display board. The PCBs are held in by 2 rotary switches. Removing the guts. Careful with the tubes. They are freestanding and might crash into the top of the case. The banana sockets are soldered, removing them for cleanup. Unscrewing the handle. It is much easier to clean like that. The feet might have been rubbery at some time, but they are pretty much hard plastic now. They need replacing. Removing the electrolytics. And somehow I feel that the handful of tantalums might also be a good idea to check or even replace this time. They look rather cheap. I tried to wiggle the Nixies before, but they seemed to be soldered in with a spacer. Turns out that these are indeed sockets, so out you go. The plus-minus switch is moving a bit sluggish. Getting ready to clean it. It looks like a rocker switch, but it is just actuating a sliding switch inside. A 4-pole one at that. Getting all the contacts in place was not as easy as the usual 1 or 2. The wafer switches are at least nice and open. Cleaning them is easy. Also, the grease is still nice and feels like new. No need to disassemble these. With fresh grease and cleaned, the switch now moves nice again. Up next, the transformer is dual voltage, currently wired for 110 volts. The manual lists the connections for 220 volt, which is close enough to our current line voltage. No need for any hacks. Sweet! I solder in the center bridge wire after removing the parallel connections on the primary coils. Putting in the new capacitors. I didn't realize that the PCB connections were little sockets, so I desoldered the outer two. Whoops! But nothing a bit of fresh solder couldn't fix. Soldering here does require a bit more scrutiny than usual. The PCB has no solder mask, so it is very easy to bridge connections. And before plugging it in and giving it a test, cleaning the bench to avoid any sparks. Ta-da! It lights up, and I see flashing digits. There is life in it. Cleaning the case. I scrubbed it with a magic eraser. That got rid of most of the ugly bits. The feet have left a rather sticky impression. I use sticker remover to soften up the goo. Took 3 turns, alternating with IPA to get the last stuff off. Yuck! Mounting the banana sockets again. I pondered putting in newer ones, but that didn't feel right. They cleaned up fine, so in they go. And now the power cord. I still have my go-to lamp cord for devices like this. It did put up a bit of a fight in the strain relief, but eventually I showed it who's boss. The display cover piece was glued to the frame with double-sided foam tape. There is quite a gap because the front panel is inset and the plastic is straight. At first I tried to double up on the stuff that I had around, but that was way too thick, so I removed one layer again. It does work, and when the guts are in place again, they push against the plastic and should keep it from sliding even when the glue should fail. Now to the big question, how does that thing fit into that small case again? I'll just put in things one at a time and hope for the best. Grounding wire? Check. Current input fuse holder? Check. The mains fuse wire was almost breaking off, so I snipped it and resoldered it. Then mains fuse holder? Check. Power cord neutral to transformer? Check. Input wires to banana sockets? Check. The mains fuse is tucked in between the transformer and the ground wire. Check. Don't forget the tooth washers on the knobs. And where is the shoehorn when you need it? Overall, the PCB fits in nicely, but there is a multi-tap transformer that has a whole bunch of stiff wires right where the PCB should go. Bending them out of the way without breaking anything is a task and a half. That AC Cal Adjust potentiometer is also right where it interferes the most. That one could have been moved to make things easier. It is butting up against the transformer where it is. And after finally nudging the last wire into position, success! Adding the fuses. Again, the mains one needs half the rating from the previous one. Oh, I need to stock up. A quick test. Yes, it does turn on. Calibration will follow in a bit. New plug. Not my favorite style. I seem to have picked up the wrong one in the hardware store. People, please put back items into the bin you took them from, not into the one next to it. Thank you. But this one will do for now. New feed. Now to the calibration. The meter has calibration test points on the rear and quite a few trimmers for ranges. I tried to follow the calibration guide but ran into a few problems. After calibrating the DC voltage to read the correct voltage from the DC test point, it says to switch into Ohms mode and tune the oscillator so that the display reads over and 0.85 with a tolerance of plus minus 15 counts. So anywhere between 0.7 and 1.0 would be okay. But my unit started off at 1.8 and the lowest I could trim it was 1.01, and that kept creeping up over time slowly. Clearly a thermal drift. Not sure why, but the trimmer was not giving enough range. So I decided to replace that trimmer and gain a bit of adjustment range. I didn't have a matching style on hand, but a bit of wire connecting it will do. After calibrating the DC voltage and ohms overflow value in several iterations, both values are close to the requested ones. But the next hurdle was ahead. The AC calibration is done from the AC test point. You are supposed to measure it and tune the test point to read a specific DC voltage, then use that tuned test point to calibrate the AC voltage. Well, that didn't work at all. I decided to use a few AC voltages on my regular benchtop meter to adjust the AC instead. And again, running out of range before an acceptable value shows up. This time the trimmer bottoms out at 0 ohms though. Clearly the fixed resistor in series with it is too large. I'm adding a 22K botch resistor in parallel to bring it down a bit, and sure enough, now the AC is at least close. Tidying up the botch a bit. If I ever need to remove the PCB from the case again, I'll swap the resistor and also check up on other values in the AC circuit, but for now, this will do fine. And after tuning the resistor ranges, time to close the lid. And that's it. A pretty neat, minimalist approach to a digital multimeter. Certainly nothing to brag about in terms of features or accuracy, but Nixies! Awesome! I hope you enjoyed this little project. See you next time! The switch plus and minus. The switch plus and minus switch. Yes, the please, darn it! Outtake in an outtake.